Hello. In this chapter of the production economics course, I will be covering the cost function essentially. The cost function follows the production function very logically. The production function, we learn what are the stages of production, what is the maximum production that can be created, when we reach the maximum, and when the output, the production, start decreasing as we are adding more input. Of course, we will have to also talk about the cost function and then profit. Ultimately, we want to know how profit is maximized. At which level do we have the highest profit? What the corresponding cost and output? So costs are divided into two main groups. We have the variable cost here and the fixed cost here. So the variable cost are the cost that the producer incurs as she's producing goods and services. So if I'm producing corn, for example, I will have to deal with seed, land preparation, fertilizer, etc., etc. Okay. If I don't produce corn, all those costs will not happen because I'm not producing. Right? So the variable costs are all the costs that result from a production process. But there are other costs, the fixed costs, that I will still incur regardless of production or not. So in this time of the government requiring people to shelter in place, to stay in their houses, many cannot go to work. And when they cannot go to work, a lot of people get let go, and they put themselves on the unemployment roll. So because there's nothing to produce, let's take a restaurant that has cook, etc. The cook will be there if food is being produced, if the output is being produced. When the restaurant is closed because of the virus outbreak, the owner has no choice but to let all the cook go because there's no money coming in, there's no way for him to pay them. If the restaurant closes and stays closed for 3 months, for example, the restaurant owner still have to pay for the insurance. If he's renting the place, he still have to pay for the rental. Those are what we call fixed cost that exist independent of the production process. You need them to produce, but you still have them if you are not producing. So our total cost is a function of is a sum, okay, of a total fixed cost and total variable cost. Okay. This is total fixed cost. Here we'll be talking about different over cost, average cost, total cost, average total cost, marginal cost. Actually, this should be average total cost. And one thing to point out is this concept here, okay, is that in our cost, in our production function, we have the output as a function of the input X. But in the cost, so you have the cost function, it's just the opposite, right? We look at how much X increases when, how much Y increases when we are increasing X. So this is Y, output and input. So this is production function. Here we have Y, and here we have the difference cost value. Okay. So there are two different functions. However, this cost function is obviously clearly dependent on this cost function because of those two here that are linked. Okay, and so the output is in a function of X. Okay, so Y is a function of X, cost is a function of Y. So we can rewrite the cost function, okay, as a function of X if you wanted to. So we can represent the indirect representation, okay, of that function by this equation here that we call the inverse production function, okay, that puts X is 1 divided by Y function. So those are the different costs, and how do you compute them? Well, they are just a total fixed cost divided by Y. Average variable cost is total fixed cost divided by Y. We can also write this in this form because the total variable cost is the input price, okay, times the quantity of input. X is the quantity of input. Okay, so that's the total variable cost. Why we cannot break down this cost here? Because the total fixed cost is not a function of output. So our property is not a direct function. Actually, no, it's not just not a function of output. And usually is a number. Is number A that can be 500. Okay. And so there's nothing to say about it. We also have over costs. We also have the average total costs, that is a total cost of production divided by Y. Okay. So it's going to be, well, total fixed cost plus PXX divided by Y. The marginal cost is the incremental cost, and so we know what the function is. And here you can see that the marginal cost equals, so this value here is the inverse of marginal physical product because marginal physical products is change in y divided by change in x. Okay, and so here you have change in x divided by change in y. So it's the inverse. Okay. Of course, this is equal, yeah, marginal physical product. So for marginal physical, so the marginal cost then, okay, becomes is the price of input time, well, the inverse of marginal physical product at the function of x. If you want to get into this a little bit more into detail, price divided by marginal physical product, okay. Let's say that marginal physical product is 1 and price is 3. That means that to increase output by 1 unit, we need 3 units of input. Okay. So for example, we consider to increase output by 100 bushel, we need to add 100 pounds of fertilizer. Okay, so that is the marginal cost tells us. So you see that, right? 1 unit requires how many units of input? So this is the shape of the total cost, okay? And of course, from our production function, we can derive the different point. So first we have the inflection point, that is nothing but the minimum of the marginal cost, right? Because at the inflection point, first we have cost that is decreasing due to increase return to scale. Then, so this is our production function, right? This way. Production function, you have increase, return to scale. Okay, and then you have an inflection point here, and then you have a diminishing return to scale, and ultimately we have negative return to scale. So when we pass the maximum here, okay, that's what we have in this area here. Production decreases, right? Y, remember this is Y. So Y shrinks after we pass the maximum. Okay, and this is the slope of the maximum. Okay, so the slope of the maximum. So when cost reaches a level, cost continues to increase, okay, but production decreases. Of course, we don't want to be there. That is basically stage 3, okay? So, so stage 3, start here. And we have stage 2 and stage 1. So at this level, you have a stage, the inflection point, you have stage 2 here. Okay, I have it there. All the way down until we output. Yeah, okay. All the way down to a point where marginal cost equals marginal revenue. The marginal cost equals marginal revenue. Sorry, marginal cost equals average total cost here. I'm talking about revenue, is not in this chapter. So marginal cost equals average total cost. Okay, at that level, right? At that level, we have the beginning of stage 2. Okay, beginning of stage 2, all the way down to stage 3, of course. Okay, now I'll have that here. So how do we obtain those minimum? Okay, those minimum value. To obtain the minimum value for the marginal cost curve, we know that we are going to derive, set the derivative of a marginal curve to 0, because that's this slope here is 0, right? So slope is 0. So when we set the derivative, that gives us a slope to 0, that we find out what the minimum for this curve, and we find that is this much. So same thing for the average cost, right? To work with average cost, the derivative of the average cost, if I can have space somewhere to work this out. So the derivative of the average cost our cost function okay. Well, our variable cost is 6 minus 0.4y is the derivative of 6 minus 0.4y plus 0.02 y squared by dy. Okay, so we take this derivative, going to be equal to minus 4 plus minus 4 plus 0.04 y. Okay, and so that's what we have here. Okay, so of course for derivative, we multiply 2 by 0.2, that will give us 0.4. So those are what the production function looks like compared to the cost function. And again, here you can see we're deriving y as a function of x. Y as a function of x. And so we'll put her here to be able to merge both functions. And so the inverse function, okay, is so basically what you try to do here is to take the production cost and flip it. Okay, if we flip it, then the y will become the numerator, and the x, the y becomes the x, and the x becomes y. And if you bring this here, right, by flipping it, so you have 2y. You have y and y, okay, and so and we have this x flip on the other side, right? So if you flip this function, then x becomes y, and y becomes x. And so we bring into this function here, if x become y, then you have y become x. So then both function will have the same independent variable, and the same variable that will be x. And they will be mirror of each other. That's why they are opposites. So opposite or inverse, right? So production functions is the inverse of a cost function or vice versa. And so if you draw those functions on a piece of paper and flip that paper, those will match exactly. So that's what I have for you in this lecture. Thank you for attending, and I will see you next time.